Hi everyone, and welcome to today's topic, which is proof. This is going to cover both proof from year 1 and year 2. And there is a theme in the past papers. I'm looking at past papers 2022, 23, 24 from the Edexcel paper 1 and paper 2. And you'll notice that more often than not, there's a proof question in paper 1 and a proof question in paper 2. One of them will be from year 1 and one of them will be from year 2. Apart from 2024 when there was only one proof question. We'll go through these fairly quickly. So the year 2 proof is proof by contradiction. That's the one that's more likely to come up in your A-level exam. And it's really common that we're dealing with integers. In this case, PQ is even, and we need to prove by contradiction that at least one of P or Q is even. So the main thing really is to understand step 1 of proof by contradiction, which is to set up your contradiction, or in other words, what you're going to assume. So in this case, we're going to assume that there are integers PQ is even, and both P and Q are odd. So there is the contradiction. For odd numbers then, we can use the notation P equals to m plus 1 and Q equals to n plus 1. It's important to use different letters when we're dealing with potentially different integers. And then we're going to multiply them to get PQ. Expand. Ultimately, we're looking to see if we reach a contradiction. In this case, we were trying to find that PQ is even. However, you'll notice that this actually takes the form of an odd number, 2k plus 1 if you like. We're always looking to factorise out a 2 and then have a plus 1 to show if a number is odd. And then all you need to do is say that this is a contradiction and come to your final statement. Therefore, if PQ is even, then at least one of P or Q are even. Just repeating the original statement. Moving on to part 2 of this question, we've got two pieces of information. X is less than 0, and we've got a inequality, and we're trying to show y is bigger than 4x. So we'll start with the second bullet point and see if we can take it anywhere, getting it closer towards the final statement. So expanding both sides or expanding the left-hand side and rearranging. And then we come to wanting to divide by x because we've got an x on both sides. However, this is an inequality, so you need to be careful whenever you're dividing both sides of an inequality, because if you're dividing by a negative, the sign will switch. And we know from bullet point 1 that x is less than 0. So we should mention that since x is less than 0, when we divide both sides by x, the inequality sign will indeed switch, which will lead us to the solution. Next question is from the paper 2, quite late in the paper, question 11, and this is a year 1 specification question. Prove that this is even for all natural numbers. And so natural numbers are your positive integers. They are formed of your even numbers and your odd numbers. So those are the numbers we need to check. We need to check your 2k's and your 2k's plus 1. You can use any letter. It doesn't have to be k. K is the one that we usually use. And so sub in 2k, and we're checking to see if we get an even result. Expand, and you'll notice that without even expanding fully, I've got a 2 outside of the bracket. So therefore that will be even. So if at any point you can factorise a 2 out of the whole expression, then you've got an even number. Moving on to the odds. This one we will need to, well, we actually don't need to expand it fully, because you can see from the second bracket, we've got numbers that are multiples of 2. So we can take a 2 out of the second bracket and not expand the whole thing. And so by fully factorising out 2, we've shown that this is also even. And then don't forget, the final mark will usually be for a final concluding statement, concluding that this will be even for all n natural numbers. Moving on to 2023, again, this one comes up quite late in the paper, but it is just a year 1 proof, and it's actually really similar to the one we just did. All natural numbers, so we're going to have to take the evens and the odds. So this time we're proving or looking to show that it is going to be an odd number. And what we want to do is take out a 2 from all of the terms, but then have a closed bracket with a +1 on the outside. And so in this case, it is just going to be, there's a +1 in my line of working out, and so all I need to do is take a 2 out of the first 2 terms to get it in the general form of an odd number. For the right-hand side, or for the odd numbers, it's a little bit longer. Again, I'm going to expand fully, collect like terms, and you'll notice we get a +7 this time. So think of it as a +6 +1. And that's good news, because then you can take a 2 out of 6, leaving a 3 inside the bracket, and then the +1 can stay on the outside of the bracket. So therefore, this is also in the form of an odd number, and so the statement will be odd for all natural numbers. Please make sure you leave your final conclusion. Moving on to 2023, paper 2. We have got a bit of a different looking question, proof by contradiction though, so it's a year 2 style question, and we've got what a student has started with, which is nice. It means we've got something to work from, and it wants us to complete their proof, where we're talking about an obtuse angle, so that's between 90 and 180, which is probably going to become relevant here, as you'll know that the trigonometric graphs will be positive or negative depending on which quadrant you're looking in. So first of all, I'm just going to expand the left-hand side, and notice here that we get a sine squared plus cos squared. Using your year 1 identity, that can be written as 1. And then if you like, you can, my initial reaction would be to use the double angle identity as well, but you don't actually have to use that here. So rearranging, we get that sine 2x is bigger than 0. But remember, this is a proof by contradiction. And so if x is obtuse, that means 2x, so double it, will be a reflex angle between 180 and 360, which is when sine 2x will actually be negative. This will be your contradiction, and therefore the original statement is true. If you didn't like it this way, you could have left it in terms of sine and cos x, and then thought about the obtuse angle, so between 90 and 180, thinking about the values of sine x and cos x then. Up to you. 2024, paper 1, question 15. Part 1 is just a 2 marker. I really like these. You do need to know how to do them though. It wants us to show that something is positive for all real values of k. There are a few ways that you can do this. You could do a sketch. I like to simply complete the square. That's the quickest way to do it, and I think the best. So if you complete the square, we get a square bracket, and then you need to sort out what goes on the outside. In this case, it will be a +1. You should know that the smallest a squared number could be a 0, so we can write k minus 2 squared will always be bigger than or equal to 0, which means the statement as a whole will always therefore have to be bigger than or equal to 1, because we're doing +1, which is positive. So therefore it will be positive for all real values of k. If you don't like that method, you could always draw the quadratic and investigate the minimum. The minimum will be 2, 1 in this case. Part 2, now we are doing the proof by contradiction. This one is a little bit long. It's 4 marks, which as a whole, we've got 6 marks here, which is quite a lot. And we're looking at 2 brackets multiplied to give 28, and they've already solved one pair of simultaneous equations for us. So they've investigated 14 and 2. So the first thing I would do is list out all the other possible opportunities or ways of getting 28. So we've got 2, 14, 1, 28, 28, 1, 4, 7 and 7, 4. But there are some other ways which you do need to consider. We could also use a negative times a negative. So just the same as I've already written down, but with minus signs in front. We'll come back to these. This question wants you to show your calculations. You can just type them into your calculator using the simultaneous equation button. That's all you're going to have time for here. And then whenever I get an answer that doesn't fit the mold, I'll just be writing a cross next to the pair. So in this, for 214, we've got y equals minus 2. That's not a positive integer, so that one won't work. And for the next one, or for the rest of them, my calculator says x will be a fraction. So I'm not even going to bother to find y because it is not a positive integer. So we'll just put crosses next to those. But you do need to show your x values so that they know that you're doing some working out. Now we need to consider these minus signs. You can keep going in the same way, but you can also notice that if x and y are both positive integers, then 3x plus 2y, that's the first bracket, so 3 times a positive number, plus 2 times a positive number, that's always going to be positive. So that immediately discounts all of these negative options. They're not going to work, which is a much quicker way than actually going through them all. When you've done that, you're finished. All you need to do is write down your concluding statement or statements. Other than these, the only other things I would familiarise yourself with is proving that root 2 is irrational, which is already written down in the textbook for you using proof by contradiction. If there's another topic you would like me to cover, please let me know. I'm looking to decide what my next topic is going to be, so any suggestions please pop in the comments. Thank you. Bye.